Hey everybody, this is Larry. This is, day one of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. Wow, I actually forgot that, this is a leap year. Huh, that's kind of, I don't know, man, I'm not prepared for this. How do you prepare for this? I gotta do something on leap day. Gotta take advantage of the extra day, I just realized now. Huh. All right. Anyway, we'll be doing these problems all week or all month or whatever. We'll just keep going. I have a 1,400-day streak, so we're just gonna keep going until I don't know whatever, right? But yeah, I think so. One thing that I've been kind of thinking about, and you've been watching the last couple of weeks. I've been getting back into fitness after coming back from traveling and stuff like that. And so one thing that I've been doing is going to the gym. I mean, you kind of have to go to the gym if you want to get back in fitness. But I've also been kind of watching YouTube more, just to kind of learn what the new technology is. So anyway, it's not that interesting per se. But my punchline here is that the way that I want to think about it is that how like all these other YouTube videos, they just kind of tell you the answer. They tell you like in a way that you can try to understand it, but then like it goes in one ear out the other because you understand it but you can't implement it. And some people can implement them because they memorize them, but they don't really actually know how to implement it without kind of like and this is where I talk about this a lot, but this is where people struggle with Q3 and Q4, the harder problems, because the harder problems is not just memorization. And I was just thinking about like, man, there must be like some sort of steroids kind of analogy here where like all the fitness influencers are like all like pretending to be perfect and normal and not on steroids or juiced or whatever, but here you get to see all the dumbness that an actual engineer makes, which is me, by the way. I'm the actual dumbness. So yeah, hopefully this is a different perspective. If you don't enjoy it, that's fine. Like then this is not for you anyway. Then you should watch one of these other channels that let you aspire and tells you that you can get big in a couple of weeks when the way to kind of fix these long term is by long term plan takes a long term solution. Anyway, all right, let's take a look at today's problem. 2966 divide array into arrays with max differences. We'll also do the premium problem afterwards in I can't English right now, in its own video. So let's get to it. Also, I need a haircut. There's so much hair. But yeah, you're given an integer array nums of size n and a positive k. Divide the array into one or more of size 3, satisfying the following conditions. Each element should be in exactly one array. The difference between any two elements in one array is less than or equal to k. Okay. Is this subsequence or sub-array? Because I look at this output and it's just okay. Yeah. Okay, so it is subsequent, or just maybe not subsequence, but it's just like the order of the input doesn't matter, right? And this is kind of a really silly daily problem because I think this is I mean, just judging by the number, I actually don't remember it enough to tell you. Like, I'm not like, oh, yeah, this is just a problem we did, like, on January 12th or whatever. I don't know. I don't know when the contest was, but the number is high, so we probably did it like 2 months ago or something. And you kind of look, and yeah, December 21st, so barely a month ago. So this problem was on a contest a month ago, and we're already doing it for daily problem. So I already have a video out for this, and I don't know that I do a better explanation for contest problems because half the video is if you actually want to see Larry live solving this problem and without all the talking, and just like if Larry wants to go, man, I'm sounding like one of those weirdos that talk to himself in third person. Maybe I gotta stop that. But if you want to see me go as fast as I can without all these intros and all these things, then you could check that video out. There's an explanation in the beginning, and then I do the live, you could see the contest, what I did during the contest afterwards. But yeah, all right. But this one is pretty straightforward. The thing is that you get to choose, right? Oh, it's not possible. Yeah, I was just trying to find. Oh, okay. Yeah. I was trying to find what to return if it's not possible. Because the way that I read this is that it's not always possible, right? But you just basically, first of all, you want to sort because sorting gives you that structure that you want in a greedy kind of way. I mean, I guess technically speaking, you don't really need a sort, though other things that you're doing will come out to be the same. Meaning, for example, if you want to say, oh, let's just keep on taking the 3 minimal number, then you could put it in a heap, and that's fine. But essentially, you're going to have a heap sort, so it doesn't matter how you want to say it. And then the idea here, then, right, is that, and the more interesting part is probably the proof. I actually don't remember if I explained the proof during the contest video, but we could go over it a little bit. But basically the idea is just greedily keep on taking the 3 fewer items, and that's pretty much it, right? So if I in range of from 0 to n in multiples of 3. I don't know how I wrote it last time, but I guess it doesn't matter. So n is equal to 3, right? Can I just write this? Just give it a slice, right? And I know that this isn't enough because I have to check that it's possible. I just want to see what that returns. Okay. I'm always like very off by 1. And then but this is of course if num sub I plus 2 minus num sub I is less. If this is greater than or if it's greater than k, then we can return empty array. Otherwise, we just do this, right? Let's give it a submit. Hopefully, I didn't make a silly edge case. Yeah, I mean, this is pretty straightforward in terms of implementation once you kind of nail down the greedy solution of choosing the 3 minimal. And the idea behind this, if you want to prove it a little bit, and how that. Wait, give me a second. Let me see how I did it during the contest. Actually, I did the contest pretty much exactly the same way. Okay, except I had the direction in the thing. But yeah, if you want to prove this, did I have a proof? In any case, the proof is pretty straightforward as well. I don't know that I proved it during the video, but that's fine. We'll do it here. The idea here is the exchange argument, right? So let's say you have 6 numbers, because that's, I mean, I guess if it's 3 numbers, it's just trivial. So you won't have to prove 3 numbers. So let's say you have 6 numbers, right? And we sort them. So let's just say right, something like that. And then here the idea is that the exchange argument is that you have 2 ways of doing it. I mean, there are actually more ways to exchange it, but this is the basic way. You can kind of figure out the other ones are kind of have the same idea, right? So this is the exchange argument, and then here the idea is that c minus a is, let's just say, is less than k, and f minus d is less than k, right, or equal to k. So then now you want to go d minus, you change that to d minus a. Are they less than k? We don't know. I don't know the. And f minus c is right. And then the idea here is that, okay, we want to compare c minus a to d minus a, and of course, I mean, I'm a little bit lazy today, but you can see that's because, and if you want to compare these 2 things, then you just subtract them, right? So d minus a subtract c minus a, something like that. And of course, the a's cancel out, so you have d minus c. And of course, from here, we know that d is greater than c, so d minus a is always going to be greater than c minus a. And you can also do the same thing for the other side with f minus d and f minus c. You can also see that f minus c is always greater than or equal to f minus d. So that means that this is always going to be suboptimal because if you do this exchange, you can only get at best you get the same answer in terms of the number. In this problem, in terms of possibility, meaning whether it's possible or not. But at worst, you can actually make a possible case into an impossible case, because this could be less than or equal to k, and this could be greater than or just greater than k, right? Same thing here, and that's basically the idea behind this proof, this greedy idea. And of course, I mean, this is I think you could kind of do some transitive things with the other things. If not, then you can also compare, like, swapping the yi with the c or something, and then do all the, I don't know. You could do a lot of exchanges, but that's the idea behind the proof, and you can play around with that. And that's pretty much the idea behind, that's all I have for this one. Let me know what you think. I mean, of course, this is going to be n log n, and O of n, space. So n log n time, O of n space, because that's the size of the output. So you can't really do better than that. I guess, yeah. That's all I have for this one. Let me know what you think. I mean, we did this from a month ago. I have a video from a month ago. So I don't know. This is very silly. But yeah, let me know what you think. Stay good. Stay healthy to good mental health. Hope you took a leap, or is taking a leap this year. I'll see you later and take care. Bye-bye.